Now in this case, we have all the elements zeros. Then we know the procedure. The procedure is we have to first form the auxiliary equation. What is the auxiliary equation? So it is the equation formed by the coefficients of the row just above the zero elements row. So this row I am having all zero elements. So above the row we have the coefficients. So with these coefficients then I can form my auxiliary equation. So how can I form the auxiliary equation? We have 0 here C1 C2 S cube row having all 0 elements, then above row is S power 4 row, and my coefficients are 2, 12 and 16. Then how to write the equation? We know already when you are entering elements into first and second rows, what we are doing, we are skipping one term in between. That means if the first element is S power 6, the next element is S power 4, coefficient of X power 4. Next element is coefficient of S square. So all are the even number coefficients, S powers. Then next is odd number coefficients. That means we are skipping one in between. Similarly, when you write auxiliary equation, we should write in the same manner. So look at here. What is the row? Corresponding row is S power 4. Then what is the first element is 2. Therefore 2 into S power 4 plus, then what is the next element? We have 12. 12 into, we should take S square, not S cube. We need to skip the S cube, so that will be 12 S square plus again skip S, then plus you are going to get 16. So this is the auxiliary equation. So auxiliary equation is formed by the coefficients of the row which is just above the row which contains all 0 elements. Now you just find out dA by ds. So the first derivative of the auxiliary equation. Then what you will be getting dA by ds, you will be getting it as 8s cube plus 24s. So now take this coefficient 8 and 24 and replace with the zeros. Whatever the zeros is there, replace those zeros with this 8 and 24 and then proceed further to complete the rows array. Now, so what will be the S cube row now? S cube row, earlier it was 0, 0, that is C1, C2. Then you just cancel those two, and here I am replacing with 8 and here I am replacing with 24. So next S square row. So how do you calculate S square row? S square row is a D1. So D1 you can calculate, we have 8 into 12 minus 24 into 2 divided by, I have 2. So for the C1 element is 8, okay, divided by 8. So that gives a D1 is equal to 6. Similarly, you can find out D2. D2 need not find out, you can directly take it from B3, that is 16 only. Then what will be the next element? S power 1. So we have even element. To find even element, we know that. So 6 into 24 minus 16 into 8 divided by 6. So it gives us 2.67. Then what is the last element? Again I can take it from directly D2, which is F1 is 16. Now we have all the elements, we completed the rows array. But in between we have one obstacle where one row contains all 0 elements. So we got a solution that using the auxiliary equation. And what will be the first column? Because in any rows array we need to look at the sign changes of the first column. So first column is like this. Now what are the elements of first column? 1, 2, 2, 8, 6, 2.67 and 6. And what are the polar signs? All are positive, which means there are no sign changes. If there are no sign changes, what does it mean? So the particular characteristic equation will not have any positive real part roots. Okay, so we can write down here the number of sign changes is equal to 0. Therefore the number of positive real part roots also 0. So since there are no sign changes, I cannot say the system is stable, because we have a special case 2. Whenever there is a special case 2, which means one row contains all zeros elements, there is a possibility of having imaginary axis poles. Now we will see how many such imaginary axis poles are there, whether they are repeated or non-repeated. If they are repeated, my system will be unstable even though there are no sign changes. If there are non-repeated imaginary axis poles, then system will be marginally stable. Now how to find imaginary axis poles? That means roots with zero real part. Now take the auxiliary equation. So we know the auxiliary equation is nothing but 2 into s power 4 plus 12s square plus 16 is equal to 0. Now I want to solve, I want to find the roots of this equation. So let us assume x is equal to s square. Then you can write it as, we can simplify it as s power 4 plus 16s square plus 8 is equal to 0. Then we can find the factors as x plus 2 into x plus 4 is equal to 0. So what is x? X is equal to minus 2 and x is equal to minus 4. So what is x actually? So x is nothing but s square. Therefore you will find one s value, one set of imaginary axis poles, one pair of imaginary axis poles are plus or minus j root 2. The other set of or other pair of imaginary axis poles are plus or minus j 2. So there are 4 imaginary axis poles. These are the roots of the auxiliary equation. Since the auxiliary equation is derived from the main characteristic equation, so I can say these roots are also the roots of the original characteristic equation. So when you locate these 4 poles on S plane, and this is my S plane, so I have 2 poles here, one is plus j2, one is plus j root 2 and again minus j root 2 and minus j 2. So I have 4 poles on imaginary axis and those 4 poles are non-repeated. Now, so what will be the summary? We know that the total number of poles are 6 because the highest degree is 6. Total number of poles are 6. Our total number of roots are 6. Roots and poles both are same. When I say roots, roots of the characteristic equation. When I say poles, poles are nothing but my closed loop poles. Now total number of poles or total number of roots is equal to 6. And from the first column it was very clear that there are no poles in right of the S plane. So number of poles in RHS, right half of the S plane is equal to 0. And how can you write this? Number of roots that are having positive real part is equal to 0. Now in this case we have extra term, that is number of poles which are lying on imaginary axis. Now we can write here number of poles that are lying in imaginary axis is 4. Just now we have seen those 4 at plus or minus j2, plus or minus j root 2. Then what are the remaining? The remaining will be 2. Those 2 will be obviously in left half of the S plane. Therefore from this I can say the number of roots of the characteristic equation with a 0 real part is 4, and number of roots having only negative real part are 2, or number of poles that are in left half of the S plane is 2. So what we can say, since there are no sign changes and there are no repeated poles on imaginary axis, we have non-repeated poles on imaginary axis, the system can be said to be marginally stable or critically stable. System will have continuous oscillations.